So thank you so much for coming to this session. And I see so many people. I'm so glad to see you all. My name is Kamal Bhatt, and I'm working as a software product manager at STORDIS. And today, what I'm going to speak about is not a product. I'm going to speak about an approach towards orchestration, automation, or you can say configuration of your infrastructure, not a single device. So when we say infrastructure, infrastructure could be made up out of several devices. It could be your networking devices, which is router, access point like things, your servers, your hypervisors, your virtual machines, your various software services. So before we move on, I would like to see the evolution of orchestration, where we are coming from. Hope I'm audible to the end. Can somebody confirm? Thank you. So we used to have CLI and SNMP-like protocols, which helped us a lot. And CLI, I would say, is still very prominent and perhaps the most reliable way when it comes to point-to-point configuration. SNMP you can still see in some legacy systems. But then we had some interesting contenders like software-driven networking. It was very interesting concept. You take out the brain, the control plane out of the switch, and you put it on a server. And that becomes a central brain for your whole network, whole infrastructure. Then RESTconf, API-like things we had. And my approach here, infrastructure as a prompt, if I would say inspired by this approach, infrastructure as code, where you can define your intention in the form of YAML file, the lengthy ones, how your infrastructure would be looking like. You can use the tools like Ansible, Terraform, Chef, Puppet-like things, but there was a limitation in infrastructure as code approach. You will have to know the syntax and semantics of the playbooks. You will have to know the YAML syntaxes. You will have to know the resources and the CLI which you are going to use in your playbooks. But in 2026, does anybody want to write playbooks or write any kind of code or script? Can we replace, who's that? Clap for him. Good. So can we replace this C with P, code with prompt? So we call this infrastructure as prompt. So that is the thing which we are going to discuss in this session. We did a POC. I will dive deeper into the POC at code level. I will show you which exact tools we have been using to achieve infrastructure as a prompt. So what is IAP? Basically, it's a human-centric shift where intent is communicated via natural language. And what could be the natural input from a human being? It could be voice, it could be image, it could be structured or unstructured text given to your chatbot, for example. So you can type in the sentences with spelling mistakes. On the other hand, you can give the input in the form of markdown, very structured markdown, or JSON or XML. AI then transforms such inputs into the structured, deterministic device configuration or infrastructure state. The intent synthesis is the responsibility of, again, so many tools in the between. I will show you what exactly I've been using. So why, what, and how is decided by AI tooling. And as we are not giving input in the form of CLIs or anything specific, technically specific, so you can apply this approach on any kind of vendor devices. So this is very much vendor agnostic approach. So here onwards, what I'm going to show you is our POC. So I will start with our top level architecture of our POC, which we experimented at STORDIS. So there were basically three areas, three major points in our POC. Agent, the AI part, the infrastructure that we tend to manage, infrastructure made up of variety of devices. Then bunch of repositories. I will explain every bit and pieces here right now. So the agent we have been using was GitHub Copilot. Now, this is not sponsored by them, but you can use any other coding agent for your infrastructure. Gemini CLI, for example, from Google, anti-gravity is the solution, Cloud Code, or cursor-like things. The coding agent in the center. Why we choose coding agent for this purpose? Because they can access your CLI, as simple as that. How is your, at first when you think of configuring a device, what is your first attempt? You open up your CLI, try to do SSH or execute some commands. So that is the power of coding agents. So I have mentioned here, there are some specifics, some artifacts in which you can configure your coding agent using some instructions, prompts, skills, and MCP. The Model Context Protocol, it's an household word in AI community those days. These artifacts could be named differently. For example, in Gemini or anti-gravity or Cloud Code, you can call them different, but the concept is same. Instructions are applied on the global level. They are applied on each and every input that is coming into your chatbot. Prompts are repetitive task, single focus task. So you can always type into your chatbot, or if you have used GitHub Copilot, but there are some repetitions between the tasks. It's better to define and structure them in a prompt file, and you can directly refer using the / command, and they appear in the dropdown and you can use them. It's so easy to use them in that way. Then there is something called skills. It's a multi-step procedure. This is actually the how-to thing that is explained to your agent. In my infrastructure, for example, I had this network documentation tool. You would have heard of, I'm sure, the NetBox. How would my coding agent know how to speak to network documentation, the NetBox service? So that's how to is defined in skills. In this case, it was like, go and search the web and find how to write a REST client, because I wanted my agent to connect to my network documentation tool via REST. It is just an example. And then MCP, everybody knows about it. And the infrastructure, which I was orchestrating using this approach, was made up of, for example, first is a service. We call this Monsoon. Monsoon is an in-house developed tool in STORDIS, which we use to monitor sonic switches, basically a telemetry service. So this is storing all the telemetry data in InfluxDB, and the use case is, I can ask my coding agent, go and fetch the, let us say, enable, disable state flaps of a particular interface in last 24 hours. I literally type it like that. And AI converts that into the influx queries and give me the result in pretty format in form of reports or so. Then GNS3. GNS3 I used in my POC as a simulation and digital twinning tool. In GNS3, you can simulate various types of network topology, and there are templates available. So you don't need the hardware really to build your topologies. It was very useful for the POC, in fact. NetBox, I have spoke about it as a network documentation tool. I was using it, and I created some dummy data. And the use case for NetBox having in my POC was, at any point of time, I can ask my coding agent, give me the deviation of my topology XYZ in GNS3 from my network documentation. Now imagine how difficult is that if you want to do that manually. It creates a report. I will show you that also, the report created by the coding agent. Then another thing was real switches. I had a couple of real switches as well in my infrastructure, so that it's not totally a simulated environment. I had some real hardware as well. So repositories, why I had repositories? By repositories, by the way, I mean the Git ones, the Git repositories. So one use case was, whenever coding agent successfully writes some configuration, performs some set operations on the device, I want that my sonic config should be backed up. So that was a use case. So it is very much like Windows restore points. You update your window and it creates a restore point so that you can roll back to that restore point at any point of time. So that was a use case. Then agents generated code. What is this? This is coding agent. Whatever you say it tries to create some code to achieve the things. Although you never need to see into that code in our case, a developer will have to, but we don't need to. But we were storing all that code into a separate Git so that we can reuse it, or other users can use that generated code at any point of time, so that coding agent need not to start from the scratch. And there were some reference designs of various types of topologies. That is interesting. Created by hand or created using some diagram tools like Draw.io as well. I will show you. I created a hand-drawn topology and agent was able to create that. So this reference design is also a kind of prompt that is used in our approach. Prompts you have defined here, but you also have opportunity to define prompts in Git as well. So I'm now diving deeper into my setup. So this is my VS Code. I'm really have taken the snapshot of my VS Code setup. So operator, this is my coding agent setup here. Repository number 2, operators generated code. And here you see the reference topologies, hand-drawn topologies, or the diagrams, whatever it could be. Then the backups. Why I'm pointing finger? It doesn't work there. So one of the skills, the how-to part, just an example. I'm not going into each and every. Who cannot see that, I will speak and explain, no worries. So one of the skill is device skill. Now from the infrastructure, I am focusing more towards the network infrastructure. I'm focusing on sonic devices to be specific in this skill. So this is a device skill. In this skill, I have explained how to speak to a device, how to configure, how to get configuration on, and how to take backup. You remember we had a backup repository there. So have a look at the first point. I believe people from the back can not have a look. I will read it for you. Most tasks can be achieved using device CLI, hence prioritize CLI. This is a coding agent. I say, okay, create a port channel, add Ethernet 123 to this port channel. It will try to write the code. But this is a simple job and can be achieved using only the CLI. So that is the instruction. And that is mentioned in the best practices. Now there are 2-3 more best practices. Then have a look at the backup operation. As I said, I want my agent to take the device backup whenever there is a write operation or configuration has been done, or user has explicitly triggered it in the Copilot chatbot. Okay, take the backup of this device, for example. And here is the procedure, how to take the backup. We had this backup repository created. Literally, I am writing, I have a local directory. Copy this etc sonic. If you guys are familiar with sonic, you would be knowing that there is a file which contains the running configuration all the time of the device. That is etc sonic config_db.json. Copy that file from the switch into the local and perform the git push operation immediately. So backup is created immediately in a specific naming format. I have defined it in skill. Copy the file, append the device IP, append the short description about the configuration. The change have happened with the timestamp. And while committing, make it descriptive. Describe what you changed on the device actually. So these are like the snapshot, the restore points you see in the windows. And what about the configuration? How does agent know what command to execute to perform XYZ operation, for example? So here at the bottom, I have written, I'll read it for you, no worries. Go into the sonic-CLI terminal. How a human does a configuration? He would do show ? What are the options available? That's exactly written here. Go into Sonic CLI terminal and execute show ? It will list all the options, then AI agent can predict or try to find out what is the best possible option to achieve user input. That might be for creation of VLAN, port channel, BGP configuration or MCLAG domain configuration, things like that. But still, if it cannot figure it out, I have also linked the user guide. That is a big markdown file. Okay, you failed to find the option. Now I have a detailed description. I have a detailed documentation. Go there and try to find out the correct procedure to fulfill the user need. Then there is another skill example, how to create a project in GNS3. We know we have nice UI, drag and drop like things, but there is a REST interface available for GNS3 server as well. The first 2 lines says that for interacting with GNS3 server, use the GNS3 REST API. Here is the link. It's not my problem at all how to write your REST client, what are the REST endpoints you will have to create to give a specific name to a project or so. So it figures it out. But still, you might be noticing a big question is not answered. That is, what are the credentials for devices, for various services, GNS3 or NetBox, for example. There is another skill. It all skill-based, infra access. Infra access is another skill that looks pretty similar. I do not have a snapshot of that skill, but it looks similar. For me, I'm storing all the credentials in environment variables. So in that file, I'm writing whenever you need to access any infrastructure entity and you want credentials, go and try to find the environment variables with the specific names. For example, GNS3 access, I would have defined GNS3 underscore host, which will be having the IP address of my GNS3 service, then GNS3 underscore user, and then GNS3 underscore password, so it can find out from the environment variable. Of course, while reading the environment variable, it will ask for your permission because that's a sensitive operation. And GitHub Copilot and I believe also other coding agents have such guardrail implemented. Now prompts, the single task. So it's an example of a prompt. Compare GNS3 topology with NetBox documentation. I did a POC. Mostly I was using the simulated environment, but for me it was the real one. So in a GNS3 topology, I wanted my agent to generate a report of the deviation. I had some documentation already created in my NetBox, and I asked my agent that use this prompt. How? If you have used Copilot, you might be familiar with the interface. So here you put / and all these prompts in the highlighted one appear as a drop down. And you need to give input. Have a look at the initial lines of this prompt. Analyze deviation between GNS3 lab topology and NetBox source of truth documentation. Input required GNS3 project name. This is pretty much specific to my POC, might not work for you, but this is how I designed it. So whenever you select this prompt, it automatically asks, okay, what is your GNS3 project name? Give me. And these 3 words, follow instructions in, were automatically added. And it started its execution. Where is my GNS3? The infra access skill was used. Where is my NetBox? The infrastructure is skill, which was defined. I shown you in the previous slide. This was used, and it finally created a report. There are many prompts which I have defined. For example, have a look at the first one, analyze GitHub issue prompt. So that is very classic place to report the software bugs for the users or testers. Yeah, but can we use the GitHub issues to report only the software bugs, not infrastructure ones? Why not? Any user can report the infrastructure issue in the form of bug in this repository, and I can again select this prompt and give input as an issue number, and I can ask my agent go and reproduce this issue by creating a simulation in my GNS3, for example. There are many such prompts defined. They are very descriptive. Of course, in the first go, I couldn't get it working. After some experimentation, what all I need to write, I figured it out, I created. create digital twin prompt, for example, create port channel prompt, for example, create topology from image that I will show you in a moment, enable ports, identify ACL overlaps, that's a classic case. Access control list table generally have overlapping entries. This can identify it for you. Identify IP conflicts.prompt.md. So there is a bunch of prompts which I have been using. So next was the previous prompts result. Compare GNS3 topology with NetBox documentation. So far, from coding point of view, what I have done? Nothing, just writing markdown files. No Python, C or C++ coding I have done to achieve this result. So this is a report produced, the deviation between network documentation and your real network, quite descriptive. It went into your NetBox instance and it went into your GNS3 topology and it created this report. Total devices found that many, total nodes in GNS3 that many, and here you have description of the configuration difference. I know that I created this dummy data into my NetBox. I knew there's huge deviation. In fact, there is nothing common between my GNS3 and NetBox documentation. So I had quite a healthy report produced at the end. I had good handwriting, I believe, and this is a multi-chassis lag drawing. This is a common case. I mean, with your team, you might be discussing on the whiteboard, can we design something like this in our network topology? So this is what I draw on the paper. This is multi-chassis lag made up with Sonic switches. On the host, I also use Sonic, although you can use any kind of Linux virtual machine. So I detailed everything here. VLAN number to peer linking to port channel, explicitly highlighting the Ethernet names, the links. This is aggregation layer. This is your host layer. I made a separation. And I fed it as a prompt to my chatbot, and it created this topology in GNS3. I also mentioned in GNS3, Sonic 404 is the template name that you will have to use. But I'll be honest, it was not as fluent as it was with the markdown prompts. It took a while. I was to go in the conversational mode with the agent to get it. And sometimes it forgot to create some port channel. Sometimes it was forgetting to create a link or something like that. But at the end, there is also such possibility. But with diagram, which worked best was this thing. This is Draw.io, the same multi-chassis lag created in Draw.io. With Draw.io, the good thing is that it produces an XML in the background. And your agents are good in dealing with the code rather than your drawings. So it also created the same MCLAG topology in fewer attempts using this Draw.io drawing. So by this time, I don't know if you might be thinking that we have solved the orchestration using AI use case already. We have achieved everything. But that's not true. There are lots of challenges. Some of you would have already identified and having question marks in their head. Before you ask any question, I will raise them. There are lots of trust gaps in this POC. First is AAA. Authorization, authentication, and accounting remains primary hurdle. I had all the prompts in my local setup. I had all the credentials stored in my local variables. Who approved this? Where is the audit trail? Where is the review of the prompts? Nothing. I was in total control. So this was a challenge. AI uncertainty. AI as a technology. What is AI? It's about predicting the next word. That's it. What if the prediction goes wrong? Even 1% chance of hallucination can cause hours of network downtime. A big question. Vendor-specific nuances are there. Feature parity. The same input like optimize for low latency might work on vendor X and might not work or can be determined differently on vendor Y, for example. Error handling. You triggered a configuration using your chatbot. What if it was triggered on 40 devices and on 20 it got successful and on 20 vendor devices it failed? Are you going to roll back? I'm speaking about my POC only. This case was totally missing there. Semantic ambiguity. If you have a look at the whole infrastructure level and you ask your such chatbot, make the network faster. In infrastructure, you have several switches, routers, access points, servers, services, software services. What do you mean by that? Absolute semantic ambiguity is there. So these are the major trust gap. There are many, but these are easily visible. Yeah. But there are ways to fill those trust gaps as well. IAP and the wipe config philosophy. If you have used any coding agent, wipe coding is quite a popular term where a developer gives input to generate some code and you get some code generated. That is basically a wipe. And then you ask for corrections and in a conversational incremental mode, you get your goal at the end. Similarly, you can do with configuration as well. I'm not happy with your configuration. Do this enhancement, make another link, make this configuration on that device. So that is applicable here as well. Wipe config, isn't it? But imagine this kind of wipe config you are doing on your real network. Is it possible at all? No. It's a big no. IAP is a fail without the second point. Digital twin. Unless you have a digital twin, you should not attempt it. In my POC, it was always a digital twin. Mostly I was experimenting in GNS3. For me, it was okay. But digital twin as an industry or as a tooling will have to enhance a lot to make infrastructure as prompt successful. So what could be the loop? You give a prompt, you generate configuration, you test it on digital twin, you verify. If successful, deploy in productions. If not, go in that loop again, wipe config loop. So there are not only GNS3, there are Container Lab, EVNG-like tools as well, which can be used for digital twinning as well. The guardrail concept, in my POC, it was totally missing, but I believe it is relatively easier to implement by defining instruction file, for example. In instruction, you can define some security aspects, some forbidden configurations, for example. So that was our attempt for infrastructure as a prompt. We did a POC. I hope you liked the session. If you have any questions, please go ahead.
What's the time invest I need and what's my skill level I need to understand all of the network basics?
Network basics. Okay, that's a bigger topic.
Because if you get anything on the configuration level, you have to understand what it actually does.
Exactly, yes. So that goes into the network certification direction. So to be a user of such a solution, of course, you will have to know the network basics, how my STP topology would look like. Yeah.
Are you planning to show a demo of this and put on your YouTube channel?
There are demos on my YouTube channel already, but not specifically focused on the Sonic. But in one of the video, I was explaining the infrastructure orchestration using Gemini CLI, for example. So
YouTube channel.
I will let you know. Please do not forget to subscribe.
Thank you, everybody.